Alright, now in this video, you want to answer this question. What does this really mean? X not a member of A intersection B complement. So you have a set A and you have another set B. Okay, but here it is the complement of set B. Alright, and you know what complement means. So we are to explain this. Alright, X, which is an element, not a member, that is what the symbol, and you cross it. Okay, if it was just that E kind of symbol, you would just say X is a member of, right? But since we've crossed it, that means it is no more a member. It is not a member. It wasn't a member before. Okay, great. Well, before we go ahead, we jump into this, I will not go into the definition, maybe I will use it, but I would like to give you an example of this, alright? Okay, great. Maybe I start with a non-example, then after we jump into the example, so that we have a basic foundation on what this really means. Okay, great. Now, when we talk about non-empty sets, let's say A and B are a collection of numbers, and the kind of numbers that are collected are whole numbers such that X can be collected, elements of A are, let's say 1, 3, 4, 5, okay? And the elements of set B are just 3, 6, 7, 9. Maybe let's make this place to be 4, so at least we have two things in common. Let's define a universal set. This U stands for that. The universal set is actually going to be the collection of elements starting from number 1 to number 10. 3, 4, 5, 6, 7, 8, 9, 10. Okay? Alright, that is great. Now, this is the universal set. This is subsets. These are subsets of the universal set, okay? Great. Now, let's talk about the element A intersection B. So that means the elements that are common to both A and B, which are just 3 and 4. Alright? Okay. When we talk about B complement, we are talking about elements that belong to the universal set, but not the set B itself. So we can list them. 1, 2, we have 5, we have 6, we have 8, we have 10. Alright? After 8, we have 10. Okay. So if you are to talk of A intersection B complement, alright? Now, we'll be having A intersection B complement. So what are the common elements between the set A and the set B complement? You can see 1 over there. You can even see 5. And that's all, right? Okay, so those are the elements common to both this and that. Now, if an element is not here, alright? For example, 2, right? For example, the element 2. 2 is not in this. Okay, so we are actually getting to this example, to this stuff, yes. So 2 is not in this set, A intersection B complement, right? Does that mean that 2 is not in A? Does that mean that 2 is not in A and 2 is not in B complement? Okay. 2 let's check. Is 2 in the set A? No, 2 is not there. Alright? So that means that 2 is not in the set A. That's right. Now, is 2 in the set B complement? Yes. 2 is in B complement. So this means that this is wrong. It is wrong to say that 2 is not in B complement. So it will be right to say that 2 is in B complement. That means that when once an element does not belong to the intersection of two sets, it means that that element actually belongs to at most one of the sets. That is, it does not belong to both of them. You know, from the intersection is a collection, so it means both sets must have it actually. So if it is not in the intersection, it means that it fails to belong to at least one of the sets. Okay, great. So that means that 2, okay, is not an element of this, but it is an element of one of them. It could be A, it could be B. It could also be possible that 2 is not even in any of them. So this question is actually a little bit tasking, alright? But let's see how we will move with it, actually. Okay, great. So here we are to explain this. If X is not in the intersection, what does that really mean? Well, it means that X is not in the set A and X is not in the set B complement, or X is not in the set A, or X is not in the set B complement. So from the illustration we just had here, we see that if it is not in their intersection, it means that it may not even be in any of them. For example, if you talk about the element 8, okay, the element 8 is not in A, the element, okay, so sorry, not 8, let's talk about B, okay, let's talk about the element 4, alright? The element 4 is in A, I can't find a particular example for this. 6, 7, 6, 7, 7. Okay, let's talk about 7, alright? 7 is not in A and 7 is not in B, so 7 cannot even come here. Great. So that means it is possible that the element does not belong to any of them, and it's also possible that the element is actually in one of them, okay? That is this or this. It is not in this one, or it is not in this one. So if X is not in the set A and is not in the set B complement, it could be in their union. For example, here, when we have A union B complement, this simply means if you want to collect them, the element that is in set A, we have 1, okay, we have 2, union with this one, so you look at it, 2, we have 3, we have 4, we have 5, 6, 8, 10. So you see that 2 is actually in their union. So this is what we can derive from that X is not in the set A and is not in the set B, or it could also mean that X is not in the set A or in the set B. That is to say, it could mean that X is not in the union of A and B complement. This is one possibility, and the other possibility is that X is not in the intersection, okay, of this. Alright, but there are a couple of other ways of representing this apart from these two. So the main thing is that when you are given this is possible and this is also possible. Alright, okay, so it's now left for you to choose which one you want to work with. Now when we say that X is not an element of the set A, this implies that X is an element of the set A complement. When we say that X is not an element of the B complement, this implies that X is an element of the set B, based on the definition of complement of sets. Okay, if you have a questioning, you can go ahead and comment that. Okay, I'm going to see it. By the way, thanks for watching. Thanks for watching.